friends, I am Chandras Mishra, and today I am going to discuss one problem of the hackering, which is coin change problem. So basically this is medium level problem of the problem solving section of the hackering. So let us start with the problem statement. So this is the problem statement as you can see on the screen. So given an amount and denominations of coins available, determine how many ways change can be made from amount, and there is a limitless supply of each coin type. So basically what is the meaning of this statement? So yes, so you can see here n is given as the number of coins. Basically n is the money or the amount, and C is the coins denominations that are given here. So you can see here we have coin of 8 rupees, we have coin of 3 rupees, coin of 1 rupees, and coin of 2 rupees. Okay, and our task is to find out how many ways are there to make amount 3 using these coins. Okay, so this is the way. So we can see here amount is 3, and to make 3, what are the options available here? That is, we can use 1 rupees coin for 3 times. It is already mentioned in the problem, there is limitless supply of each coin type. Okay, so any number of time we can use that coin. So 1 rupees coin we have used 3 times, so it will make 3 rupees. So this is the first way that we can do. Second is we can use 1 coin of 1 rupees and 1 coin of 2 rupees, and this is mentioned in the coin section. We are having 1 rupees coin, 2 rupees coin, 3 rupees coin, and 8 rupees coin. So we can use this 2 rupees coin and 1 rupees coin. It will make 3 rupees. That is the given amount. So this is the second way to make it. And another way is to use 1 3 rupees coin to make this. Okay, so this is the third way. Only these 3 ways are there to make rupees 3. We cannot use 8 rupees because 8 rupees is greater than our amount. That our amount is 3 rupees only, so we cannot do that. Okay, so this is the problem statement. Hope you have understood this problem. Now the function description is given here. Complete the get wage function in the editor, that is on the HackerRank. We'll see how we complete that that function on the HackerRank. Okay, and the output is what? The number of ways to make changes. Okay, that is the integer number that we have to return here. Okay, suppose here we have 3 ways to make changes, so in the return we will have 3. That is the only thing that we have to. Sample test cases are given. Okay, so you can see here 4 test cases are given here. Okay, and we have points 1 2 3. Okay, basically 4 is the amount, and we have 3 coins, that is 1 2 and 3 rupees coins. Okay, So what are the number of ways to make 4 using these point 1, 2 and 3? Okay, so here amount is 4 basically. Okay, so again we can see what are the ways to do this. So you can see here we have 1 rupees coin, 2 rupees coin and 3 rupees coin. Okay, and the amount is 4. So the simple very first case is what we can take 1 rupees coin 4 times and it will generate amount 4. Or another way is we can take 2 rupees coin and 1 rupees coin and 2 rupees coin. So it will make 1 plus 1 plus 2 equals to 4. This is the another way to do this. Another one is we can use 2 rupees coin to make 4, and next one is we can use 1 rupees coin and 3 rupees coin to make amount 4. So basically there are 4 ways to do this. So our return will be, what we will return just 4. So this is the problem statement. What are the constant given here? The coins will be from 1 to 50 and the amount will be from 1 to 250. Okay, these are the constant that are given here. So algorithm is what we basically we can do. We can solve this problem using recursion also, but that will take a lot of time complexity in the recursive calling. It will take a lot of time to calculate the problem. So what we can do, we can just use dynamic programming to solve this problem. So here we are going to see dynamic programming approach to solve this problem. If we are using tabularization, it will reduce our time complexity. Somehow it will take some space, but if we are talking about time and space trade-off, if we are able to reduce the time complexity of any algorithm using some space, so we should go for the reduced time complexity and with increased space complexity. So basically this is the concept of dynamic programming. We are using tabularization. So basically what is table? Here we are using 2D array to store the calculated result. Okay, and the size will be of n cross w plus 1. Here that is the size of the table, that is 2D array, where n is the you can say number of coins available, and the w plus 1, w is the amount, and w plus 1 is the total size that will take. So there will be n rows and w plus 1 columns in the 2D array. So what we'll do, we will repeat for each coin and fill the table using following rule. What is the rule? If the j is less than coin, j means the jth index of the table is less than the coin value. In that case, what we will do, we'll copy the content of the above row in the table. Otherwise, the value of table ij will be value of table I minus 1. It means the value in the upper row of the same column plus value in the same row and j minus coin I. What we will do, we will subtract the coin value from j, and we'll see at that location. And after filling up the table, we'll return the n minus 1 and w. This is the last cell of the 2D array, and that will be the result of this problem. Okay, So let us see how can we do this. This is the code, so that we are going to see how can we make the table for this. Okay, okay, fine. So we are going to make one table. For that, we'll first fill up the base case and then we'll move forward. Okay. So basically we are going to make the table. Okay. So in the sample test case we had seen, we had 3 coins of denomination 1, 2 and 3. So what we'll do in this table, in the row side we'll have the coins. Okay. So this is for 1, okay, the coin value 1. Okay, this is for coin value 2. This is for coin value 2, and after that we have coin value 3. Okay, and in this column, what we will have, will make this column from 0 to amount. Okay, so we'll start from 0. So 0, this is for column 0, and then 1, then 2, then 3, and in the last we'll have 4. Okay, so because 4 is the amount, so we'll create columns from 0 to n. That's why we have created size w plus 1, where w is the amount. Okay, that we are going to take. Okay, fine. So now we'll start filling up this table. Okay, so what is the rule for filling up this table is what? If we want to make money 0, in that case, what is the contribution of this 1 rupees coin? So what is that? What are the way to make 0 using this coin? So basically we should not be confused here. What is the way? Only one way. What is the way? If we will not include this coin, then obviously the amount is 0. Same will be with 2. If we are not including 2 rupees coin, it will be again 0. For 3 rupees also, it will be 0. So in the zeroth column, what we'll do, we'll fill up 1, 1, 1. Okay. Now we are going to the second column, that is 1 rupees coin. So for making 1 rupees coin, how many ways are there? Okay. So to make 1 rupees coin, only one way is there. We can make the 1 rupees using this coin. So what we'll do, we'll just fill up 1 here. So is it possible to make 2 rupees using 1 coin? Yes, we can take 1 rupees coin to make this. Again we will fill up 1 here. For 3 rupees coin, again it is possible. 4 rupees, again it is possible. So what is the meaning of this? We can make 1 rupees using this 1 rupees coin. We can make 2 rupees using 1 rupees coin. We can make 3 rupees using 1 rupees coin. We can make 4 rupees also using 1 rupees coin. That's fine. We have created this first row. Now we are going to the second row. So if we include this 2 rupees coin, then what are the ways to make 1 rupees using 2 rupees coin? So basically what we'll do, we'll use shortcut here. if the coin value is greater than this column column value or column index, in that case we just copy from the above. Okay, so what we'll do, we'll just copy 1 here. Okay, it means including 2 rupees coin we are not going to have any new way, because it is not possible to make 1 rupees using this 2 rupees coin. So we'll just copy the only available ways. Now we are at this place 2 rupees. Okay, so is the way to make 2 rupees coin? Yes. So in this case what we'll do, we'll just copy this above one, that is 1 plus 2 minus 2. What we'll do, we'll subtract this coin from this value 2 minus 2, that is what, 0, and we'll see the value in the same row at the 0th column, so that is 1. So what we'll do, 1 plus 1, that is 2. Okay, now come to this point, that is 3 rupees coin. Again we'll copy the above one. Okay, 1 plus 3 minus 2, that is 1. So we'll see in the same row on 1. Okay, what we are doing, we are subtracting this coin value from this money value. Okay, so 3 minus 2, that is 1, and we are going to see in the first column in the same row, that is 1. So what we'll do, plus 1, it will become 2. Now for 4 rupees, what we'll do, 1 plus 4 minus 2, that is 2. So we'll see on the second column in the same row. Okay, that is the value is 2. So 1 plus 2 equals to 3. Okay, what is the meaning? If we exclude this 2 rupees coin, then we are having only one base. If we include this 2 rupees coin, in that case 1 rupees plus 4 minus 2, the number of ways to make 2 rupees, that is 2. So 1 plus 2 equals to 3 rupees. Okay, that's fine. Now we finished 2 rows. Now come to third row. For 3 rupees, again the coin value denomination is greater than this value. So what we'll do, we'll just copy from the above row, that is 1, here it is 2, and now come to this point. So 3, what we'll do, we'll subtract the coin value from this 3 minus 3, and we'll see at the 0th column in the same row, the value is 1. So what we'll do, we'll add 1 in the above. So 2 plus 1 equals to 3. Again come to this point. So here we have 4. So 4 minus 3, that is 1, will go to this one, that is the 1. So what we will do, 4, for making 4 rupees using 3 rupees coin, we'll just copy this one, 3 1, plus we'll add 4 minus 3, that is 1. So we'll see the value in the first column in the same row, that is 1. So 3 plus 1 equals to 4. So here you can see in the last row and last column we are having value 4. So for this we'll return, what will return? We'll return 4, and this is our answer. Okay. So this is the way how we have created this table. This is the very efficient way to solve this type of problem. This is the DP concept. Here we are using this memory space to save or calculate the value using the previous value. Fine. So hope you understood the problem. Now we are moving to the coding section. Fine. So you can see we are here we are on the HackerRank. So same problem that we have discussed. Okay. Now what we want to do? We want to submit the code for this. Okay. So we'll simply use C language to solve this problem. Okay. So let me illustrate it. So you can see this code. What we have done, we have just completed this point change uh, function that is given in the problem. Okay. So W is the amount and N is the number of denominations that are given to us. Okay. So here what we have done, we have just created one array, that is A of size N. Okay. I, W and J are the variables that we have created, and after that we have used unsigned long int data type to create a TP of size N and W plus 1, where N is the number of coin and W plus 1 is the amount. Okay. Suppose N equals to 4 or and W equals to 15. In that case, we'll have a DP. It means 2D array of size 4 and 16. Okay. And what we'll do, we first of all we'll scan the points that are given. So for I equals to 0, I less than n, I plus plus scan a percent a, ampersand a of I. So what we have done, we have just taken the denominations. Okay. After that, for I equals to 0, I less than I equals to 0, I less than n, I plus plus. For j equals to 0, j less or equal to w, j plus plus, dp ij equals to 0. It means what? We have initialized our table with 0, dp table with 0. And after that, what we have done, for I equals to 0, I less or equal to w, I plus plus. Okay. If I is, I modulus a0, it means in the first column, for 0 rupees column, what we are saying, I modulus a of 0 equals to 0, in that case dp0 I equals to 1. So basically what we are doing, in the first column we are filling up 1 1 1. Okay. And after that, what we have done, for I equals to 1 and I less than I plus plus, it means we are moving row wise. Okay, filling row by row. We are filling the table row by row. So for I equals to 1, I less than n, I plus plus. For j equals to 0, j is less than or equal to w, j plus plus. Basically this is the column, representing column. Column means money. It is representing from 0 to, that is the money or amount. In the previous case that we have discussed, we had seen that was 4. So 0 to 4. What we are doing, if j minus ai, it means the column value minus a of I, that is the coin value, j minus ai is greater or equal to 0. In that case, what we will do, dp ij equals to dp I j minus ai plus dp I minus 1 j. What we are doing, we are adding the upper row value with the value that is existing in the same row but in the j minus ai column. Whatever value is there in the same row, ith row, and j minus aith column, will add that with the dp I minus 1j. What is the meaning of this? It means we are just adding the value in the above row with the value that is existing in the same row but in the j minus ai column. Only in the case if the difference is greater than 0. Suppose the difference is not greater than 0, it means what? If the value of the coin is greater than the column value, In that case, what we will do, we will just copy the above value. It means whatever the value in the above row, I minus 1 row, we'll just copy that value into the ith row. We'll do nothing, because if the coin value is less than the amount, we are not having any way to add some way in that. So this is the only very simple code to implement that TV table. And in last, what we have done, we have just written dpn minus 1 w. That is the last cell value. And now we can just submit this code. Okay. First of all, we will run this code. So sample test cases are passed. Now submit this code. Yeah, we have passed all test cases. You can see this is a message from hacker. So this is one medium level problem from the hacker end. Thank you.